The sun almost ended civilization. Not in ancient history, not in science fiction. On July 23, 2012, a billion-ton cloud of magnetized plasma tore through Earth's orbital path at over 7 million miles per hour. It carried enough energy to collapse every power grid on Earth simultaneously. Scientists estimated the damage at $20 trillion, roughly the entire U.S. economy. Not from a war, not from a weapon, from the sun having a bad week. We missed it by 9 days. That is the only reason the lights are still on. This is space weather, and most people have never heard of it. Before we talk about what the sun can do when it's angry, we need to understand what it's doing right now. While you're watching this, at this exact moment, the sun is bombarding you with a stream of charged particles, electrons, protons, plasma, moving at over 1 million miles per hour, every second of every day, for 4.5 billion years without stopping. Scientists call this the solar wind. It never turns off. Earth is protected by something most people never think about: our magnetic field, an invisible shield generated by our planet's rotating iron core. Without it, the solar wind would do to Earth what it did to Mars. Mars once had a thick atmosphere. It once had liquid oceans. Billions of years ago, it may have harbored life. Then it lost its magnetic field. The solar wind spent billions of years stripping the atmosphere away, particle by particle, layer by layer, until nothing was left. A potentially living world turned into a frozen, airless desert. That is what the sun does on a quiet day. When it loses its temper, everything changes. A solar flare is what happens when the sun's magnetic field snaps. The sun is not solid. It is a massive ball of plasma, and plasma does not spin as a unified mass the way Earth does. The equator spins faster than the poles. The magnetic field lines wind tighter and tighter, and eventually physics says enough. The field snaps. In that single moment, it releases a burst of energy so violent it would defy imagination if the numbers didn't make it real. A major solar flare releases more energy in minutes than the entire world uses in a year. But here is the part that should concern you. It doesn't release that energy as heat you can feel. It releases it as X-rays and gamma rays, moving at the speed of light. That means it reaches Earth in exactly 8 minutes, the same time as sunlight. No warning, no countdown. It's already here. Flares are classified on a scale: C, M, and X. X is the most violent category. In 2003, instruments recorded a flare reaching X28 before the sensors were completely overwhelmed and stopped working. We never captured the true peak. To this day, we don't know how powerful it actually was. But a solar flare, for all its violence, is only the beginning. What comes next is worse. If a solar flare is the gun, a coronal mass ejection is the bullet. A CME is a billion-ton cloud of magnetized plasma physically ripped off the sun's surface and hurled through space. It carries its own magnetic field embedded inside it. And when it reaches Earth, it doesn't just pass through. It slams into our magnetic field and distorts it, compresses it on one side, stretches it on the other, violently shaking it back and forth. And here is where the physics turns dangerous. A shifting magnetic field induces electrical current in any conductor sitting inside it. Every power line on Earth is a conductor. Every transformer, every pipeline, every grid. When a powerful CME shakes Earth's magnetic field hard enough, it pushes currents through the entire power infrastructure at once. Not the kind that trip a breaker. The kind that physically melt transformers. Transformers that take months to manufacture. Years to replace. The fastest CME ever recorded moved at over 3,000 kilometers per second. It crossed Earth's orbital path in under a day. It missed us. Had it connected, the estimate from NASA physicists is not a power outage. It is a collapse. Infrastructure dark for months, possibly years. A society that runs on electricity, suddenly without it. Our only warning system is a single satellite positioned 1.5 million kilometers from Earth. A fast CME crosses that gap in under an hour. Some events give us as little as 15 minutes to prepare the entire planet's power grid. 15 minutes. When a CME strikes Earth's magnetic field, the resulting disruption is called a geomagnetic storm. The CME is the punch. The storm is the bruise. Depending on the strength of impact, a storm can last hours, sometimes days. During that window, things begin breaking in ways most people never expect. On March 13, 1989, a geomagnetic storm struck Earth. The Hydro-Quebec power grid, serving the entire province of Quebec, collapsed in 90 seconds. 90 seconds. 6 million people. No electricity. Freezing temperatures. In the middle of winter. The outage lasted 9 hours. The storm was so intense it pushed auroras as far south as Texas and Cuba. People who had never seen the northern lights in their lives stepped outside and found the sky burning red. And that is the thing about auroras. They are not decorative. They are not a gift. They are the visible result of charged particles forcing their way through the weakest points in Earth's magnetic shield. The prettier the display, the more violently the field is being hammered. The 1989 storm was a moderate one. The worst one on record is a different story entirely. September 1, 1859. British astronomer Richard Carrington was sketching sunspots at his observatory when he noticed something he had never seen before. A sudden blinding white flash erupted from the sun's surface. So bright he could see it in full daylight. He wrote it down, marked the time, went home. 18 hours later, Earth took a direct hit. The fastest coronal mass ejection ever recorded, arriving so quickly because a previous CME had already blasted through the solar wind ahead of it, clearing the path like a bowling ball thrown down a lane someone had already cleared. The auroras that followed were visible at the equator, in Cuba, in Hawaii, in Colombia. Gold miners in the Rocky Mountains woke at 1 in the morning convinced the sun had risen. The sky bled deep crimson red. The most advanced technology at the time was the telegraph. The storm induced such violent electrical currents into the lines that operators received electric shocks. Papers on their desks caught fire. Some operators disconnected their equipment entirely and discovered they could still send messages using only the current the storm itself was generating. That was 1859. That was the best technology humanity had. If the same storm hit Earth today, damage estimates begin at $1 trillion. And that number assumes the infrastructure survives at all. But here is what makes it worse. Tree ring data from 774 AD reveals a solar event that released 20 times more energy than the Carrington Event. 20 times. We do not know what caused it. We do not know if it is coming back. We do not know what it would do to the world we have built. The sun is not random. Its activity follows a cycle, rising from calm to violent and back every 11 years. At the peak of each cycle, called solar maximum, flares, CMEs, and geomagnetic storms all increase dramatically. In 2019, NASA and NOAA predicted the current cycle would be weak, manageable, below average. They were wrong. Solar Cycle 25 surged well past every prediction. It produced the strongest geomagnetic storms in 20 years. In May 2024, auroras appeared as far south as Florida and Texas. People photographed them from cities, from suburbs, from living room windows. That was not the last event. We are currently at solar maximum, the most active, most dangerous point in the sun's cycle. And a 2025 study concluded that a hidden 100-year cycle, controlling the 11-year one, may have just turned over, meaning the next several decades could bring the most intense solar activity in living memory. We built our entire civilization during the quiet part. Our warning system is a satellite called Descovar, positioned 1.5 million kilometers from Earth between us and the sun. When a CME passes it, scientists detect it and issue an alert. Then the clock starts. In a fast event, that alert comes 15 minutes, sometimes less, before impact. 15 minutes for power grid operators across the entire planet to begin emergency shutdowns. to protect transformers that cannot be replaced in less than a year. It has never been tested at full scale. There are plans. There are protocols. There are conversations in government offices about what happens if the warning comes at 3 a.m., about what happens if it comes during a geopolitical crisis, about what happens if the satellite itself is damaged by the event. We do not yet have answers to those questions. What we do have is a published estimate based on peer-reviewed research, placing a 12% probability of a Carrington-level event striking Earth in the next decade. Not in 1,000 years. Not in 100. In the next 10. The sun almost ended civilization in 2012. Not with a comet. Not with a collision. With weather. Space weather. Invisible, silent, and moving at 7 million miles per hour. We missed it by 9 days. The question scientists are no longer debating is whether it happens again. The question is when, and whether the 15 minutes we have to respond will be enough. Because beyond the danger, there is something worth understanding. The same sun that nearly destroyed our civilization also made it possible. Every photon that ever powered a plant, every ray of warmth that kept an ocean liquid, the same star, the same energy. We have always lived with space weather. We are only now beginning to understand it. If this journey made you think, subscribe and join us as we explore the unknown together.